The two certainties of life are death and taxes. In applications, there are three: managing more data, paying more to manage more data, and operating faster to deliver better performance on more data to your users. RavenDB 5.3 was released to attack these ongoing challenges. It begins with a compression algorithm that reduces your cloud network costs by 50%. It includes an ETL to Elasticsearch. You can easily leverage the best of all worlds by transferring selected data from RavenDB to Elasticsearch using our Management Studio GUI. You can also implement the PostgreSQL protocol, opening up a world of powerful business intelligence tools to process, transform, and analyze your data by creating intelligent reports to uncover new insights. Using incremental time series, you can now increase or decrease your time series values by a chosen number. You can create instant metrics like hourly sales, a 30-minute moving average for stocks, or number of people who walked through your store in the past day. Concurrent data subscriptions give you more than one subscription worker consuming documents from the same subscription. Today, RavenDB CEO Oren Amy shows you how to stay consistently competitive in our forever-changing data landscape using these new enhancements. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy our presentation, and here's Oren.
Hi, everyone. Thank you very much for showing up for this webinar. I'm really excited about this, mostly because I've spent the past few days prepping for that. And somehow we got into this really interesting situation. Just to give you some numbers, I actually run the numbers right now. We are going to release the 5.3 release next week. It's been less than 6 months than a previous release, and that was an LTS release. So that's actually more impressive. And we have a whole bunch of commits. More than 25 people have contributed code to this release. And actually, somehow we messed up. I didn't realize that we have so many things going into this release. And it's actually, from a marketing perspective, a problem. There are too much of a good thing. We might lose focus on all of the things that we have delivering all at once. So the primary focus that we have for this release is the notion that we want to make everything easier. This is not an upheaval sort of release. This is just, okay, let me give you more and more and more and make things easier and nicer to have. The fourth feature that I want to talk about is called Concurrent Subscriptions. Now, a subscription in RavenDB is a persistent query. You can go here, on window. You can go here and define a subscription from orders. And you will get it. And that's nice and everything. And now you can register that in your code. And the whole idea then is that RavenDB will then serve as a reliable mechanism to give you a bunch of documents that match your query that you can process. This is widely used for processing backend operations, for doing all sorts of backend operation, messaging systems, reliable operation, or the whole thing. A key aspect of subscriptions is that there can only be one subscription at a time. So one worker on a subscription at a time. So the technology is very simple. We have this subscription, and you can see it, and currently no one is connected to that. If I were to connect to that and start pulling data, that would mean that I have a worker attached to that. And that's perfect. That worker would start getting documents from RavenDB until all of the documents that match that particular subscription are done. Okay, what's next? We're not done yet. RavenDB will keep pushing me any new document that match the query. So I can use that to do online operations. At the same time, this is a reliable mechanism. If the server dies, if the client crashes, whatever, I can keep going on. In order to handle that, we required that there could be only a single attached worker at a time. Now, this works great until it doesn't. And it doesn't when you start wanting to go to do some expensive operations. For example, make a call to a remote third party. Even worse, make calls to different remote parties. So let's say that I have a subscription. Let's do it from here. Let's say that I have a subscription. Here we go. And this is my subscription. I'm now going to do, I don't know, item.result charge. And that's how I'm going to handle processing of the orders. Now, this is for Visa. This is fast. But I may also be paid by Bitcoin, which is slow because I need to wait for the system to settle. Well, what's going to happen then to my entire system? I have one concurrent subscriber, only one allowed. So a single slow operation is going to slow everything down. And it turns out that this is a serious problem for some of our users. So we set out to fix that. But that led to a bunch of problems. As it turns out, the concept of processing the documents for the subscription in order is something that users have come to rely on. The fact that this is reliable is something that we have to consider. So what we do, so we had to deal with that. For example, one of the things that we are most concerned about, what happens if I'm in the middle of processing an order and I have multiple concurrent workers, and that order was modified again, at which point another worker would also pick up the modified order. Another worker would now be running that at the same time that the old worker is also running that. And I have a race condition with myself on a single document. So we had to sit down and rethink how we are handling subscriptions entirely. Right now, subscriptions allow you to either use the single user mode, only a single worker is attached to the subscription, or all workers that attach to the subscription can specify that want to run in a concurrent mode. We require this to make sure that there are no expectation of serial work going on. Now, this is where it gets interesting. We are no longer guaranteeing that you will process the documents in the order that were modified. What we are guaranteeing is that for every single document will be modified, will be processed by at most one subscription at a time. So if I have an order and I started processing that and it was modified again while I was processing that, it will not be sent to another worker. We will need to reprocess that again, but that would have to wait until that batch for that order is acknowledged by the cluster. In general, you probably don't really care about that. This is the sort of thing that we build, so you don't really need to think about this. The whole idea is that you write your code and you can assume that you're not going to be racing with yourself. And that's it. That's the whole thing. Now, I want to give you some idea about how this looks like in code. So let's take a look and see it here. Now you can see that, okay, here I'm opening a subscription. Notice that I'm specifying this is a concurrent worker. And then I'm running that. I can run multiple concurrent subscriptions on the same process. I can also run them on different processes. And this leads us to some interesting observations. Right now, it means that I handed a batch to a worker, and if there are other workers available, they can start processing batch in parallel. If there is something that causes one batch to be slow, it doesn't stop everything. Now, obviously, if all of your batches are slow, if you hit something that causes all of them to slow down, well, that's what you have. But for the most part, we see that this can significantly reduce the operational overhead of working with these sort of things. Furthermore, and something that I think is really quite interesting, when we're using this, when we're using it in this manner, we are seeing that effectively we have an embarrassingly parallel problem. For the perspective of RavenDB, the processing of the subscription on the server side, sending and acknowledging all of the batch documents, this is something that happens serially. And the concurrency is actually happening here. So this will happen concurrently. And we've tested that with even as little as 2 milliseconds of processing time per each item. And we see that you see the typical scenario. The more worker you add, the faster things become. Plain and simple graph, and that's really nice to see. On the other hand, if this is relatively fixed in the amount of time that it takes, then you're probably not going to see any significant change in performance. You may even see a decrease in performance, and we measure a maximum of about 5 to 10%, if I remember correctly, if you're running in concurrent mode and there is no need for that. It's important to understand you have to opt in for this feature, and it matters because you may be running concurrently and without the guaranteed on the order. So this is again something that I think going to make certain specific scenarios so much easier. Oh yeah, forgot. This is a feature only on the professional and This is a feature only on the professional enterprise editions of RavenDB, but subscriptions themselves continue to be available throughout. Okay. Now let's talk about this thing. Incremental time series. In 5.0, we introduced the notion of time series for documents. The idea here is that you can have things like this. Where is employees? And here is the heart rate of a person over time. You can plot that. Apparently he went up the stairs or something here. That's it. Now, this is some really interesting feature. But it turns out that there is an issue here. And the issue here is that the API that we provide is an API that allows you to do an append, which effectively says, append this value to the time series at a particular point in time. Now, if we're thinking about something like heart rate, that makes perfect sense. At any given point in time, you have one particular heart rate. Well, that's the way it is. But it turns out there are many scenarios where you don't actually have the value. You have some portion of the value. And I think that what is probably the most common scenario for that, if I want to have the number of views on a post, every time that I'm doing a page load for a particular post, I'm going to want to increment a value. And okay, so what's the problem? That's easy to do. The problem is, what happens if I have concurrency? I have two threads at the same instant trying to do it at the same time. Time series allow for one value per timestamp when it has millisecond precisions. So two operations at the same millisecond, and you're done. One of them would override the other. You don't want that. So that little tidbit actually meant the time series were going to make it so much harder for us to handle this scenario. So we actually sat down and thought about that and realized that, hey, we already have a feature specifically to count how many views we have for a blog post. That's the distributed counter support inside of RavenDB. And we can actually see it here. It's perfectly fine for two people at the same instance to click 5 stars. And RavenDB will do the writing and give you the final value across everything. So what's the problem? The problem is that in this case, I want more than just the total tally. I want to know how it looks like over time. And this is where we introduce incremental time series. The idea here is that instead of using the append mechanics, which set a value at a particular point in time, we're going to use the increment mechanic. And basically, two concurrent operations on the same timestamp, on the same millisecond, whatever they happen on the same server or on different servers, are all going to converge into the same total value. So two concurrent runs of this at the same milliseconds are going to give me 2 in that particular milliseconds in this time series. Now, we actually run into a problem. We try to make time series incremental and non-incremental at the same time. It turned out there are many edge cases along the way. So we decided that we cannot support that in any meaningful manner. And we created a dedicated API for that. So now you have the notion of incremental time series, which has the increment method, and incremental time series require this prefix. I don't particularly like that, but this significantly simplify how things are going. Now, let's see how this looks like. You can see here, this is basically the code. I wrote something and I'm incrementing the number of views on a particular time. Let's go to product 77 and see how this looks like. You can see this is the incremental value. And notice that here we have 9. Throughout all of my experiments, I would always add 1 here. Or +1, -1, those sort of things. So you can see how those values are converging into however many calls I had at that particular time frame. And now I can see something really interesting. Okay, look here. This is the total amount. Now I'm doing that on a second basis, but you could also do that on a millisecond basis, something like that. So now I can ask a question like this. Let's do that on a 15 minutes range. Show me the number of views on this post. You can really quite nicely see how this looks like. So I posted that and I had lots of posts, and then it started to die down, something happened, blah, blah, blah. I can also say, and actually I probably want to do this. So here is the total number of, the sum total of views that I have in every 15-minute period since this is tracked. And I think you can imagine how useful that is. Notice that I can also take this further. Say, hey, just give me 1 value. Not the right value. So there is actually a bug in the studio because of this. So this is the total number of views that I have for this blog post, for this product. So the whole idea is that this is the sort of code that I have to write. And I don't care about when it happened, how it happened, but then I can start pulling all sorts of really interesting details around that. And it turns out that this has quite a few use cases that are really, really interesting. So you can see this is available on additions. And let's talk about some of those scenarios. A really common scenario that we have is the notion that we want to have rate limits. So let's say that my rate limit is you have a maximum of, I don't know, 15 calls within a minute and a maximum of 50 calls within 10 minutes period. How would you build something like that? So as a reminder, 50 calls per minute, 50 calls in 10 minutes period. And if you ever used Let's Encrypt or any of the heavily monitor services, you know that those are the sort of rate limits that they impose because they have to deal with a lot of abuse. And if you think about it, especially if you're running in a distributed environment, this become really hard to do. With RavenDB and incremental time series, you just, every time that you do it, you do this. You call increment on the operation. And now I need to do something. Okay. Between, let's say, so what I'm actually saying here is, no, sorry, this is the wrong thing. Let's look at the raw results. Okay, so the last thing that I have here is this guy. Okay, so now I'm going to ask like this. And let's say that you want to go 1 minute back. 1 minute back. Okay, what's your problem? Should be like this. Yes. Okay, and so again, we have a studio bug, but now you can see this. So what I'm asking here is for this period of 3 minutes, of 1 minute back, I can see that I had a total of 4 calls. Very good. How about if we go 10 minutes back? Oh, okay, so now we are not good because this is my business. And now in the span of just, 2 queries, I can so very easily figure out whatever I'm within my boundary, not within my boundary, and all of the complexity that is typically involved between rate limits have just gone away. In a very similar manner, we can talk about usage-based billing. It's very common these days if you have software as a service that you charge based on something. Let's say that you have some service that I don't know, send pictures of cats to people, and you're charging them based on the size of the picture. So you can go here. Every time that you send a picture, you increment that by the number of bytes. And then you just query. And the nice thing about this is that this gives you metrics, audits. You can see, show me how much I was charged or how much I was using over time. So all of that is directly there for you. You don't really have to do a lot of work around that. So that's something that I'm really excited about. I think that's opening specific scenarios and make them a lot easier. Now, let's talk about Elasticsearch. Elasticsearch is, well, it's a search engine. So let's go and open that. And I think this is the one. So right now I'm running this one here. If you want to run, you can, if you want to run this demo, you can go here. This is Shodan. This is, and you can go here and try to find any open Elasticsearch instance in the world. Some of them have quite a lot of data. And apparently, this is something that people routinely scan and find some really juicy targets. But anyway, right now I have this internal index. Then you can see I have nothing in here. Completely empty search server. So I'm going to go here. I'm going to say, you know what? I already have something that caused me to want to push data to Elastic. Maybe I already am using that. I'm using Kibana. I have a ELK stack that I'm using, or whatever. So I'm going to define Elasticsearch ETL and push to search. And if I remember correctly, I'm using this guy. Localhost. Right. Okay, no authentication because who needs that? Good enough. Now let's go to employees. And now I can do really interesting things. I can do transformation. And let's show this here. Now this is going to start to run. Let's see what I have here. First of all, RavenDB already, oh, I don't have an index for that. I'm going to go ahead and create one. This is part of the methodology that we use, that we're going to just do the right thing for you. And now you can see here all of the details that we have from the system, from RavenDB. And let's look at this guy. Laura Callahan the first. Let's make her Laura Callahan the second. And run this again, and it was updated. So this is basically it. This is a feature that is intended to allow you to move data, transform that, filter that, all of the usual things that you can do with RavenDB. And it does things immediately on the fly. It allows you to store your data inside of RavenDB and still integrate with your Elasticsearch stuff. It is reliable, so if Elastic is dying or is slow, you don't care. RavenDB will pick up when it happens. And that's about it. I should mention probably that the ID field that we have here must be set as keyword. Otherwise, we wouldn't be able to process it properly, because it would be analyzed and we wouldn't be able to search on that as we should. But that's about it. And this is available on Professional Enterprise. And let's see. Oh, this is fun. So one of the things that we did in this edition is we made RavenDB talk in Postgres. So the whole idea is that I can now go and open a Postgres client and execute commands. So what you can see here is me using pSQL, so PostgreSQL command line client, to run this command line. And I can do it like this. And you know what? How about this one? I can even okay, sorry. That requires me to do as S. And here we go. So I can run RQL queries from PSQL. And that is really, really interesting. Because what we did, we are talking in the wire format, but we're still using RQL. And everything works. Well, most everything. It turns out that a lot of clients are issuing many stupendously complex queries behind your back. But we made that work. So you can run a query and you get the results. Currently, this is marked as experimental. As you can imagine, we are looking into quite a lot of work to make this a complete solution. You have to both mark it as experimental and enable that. This is inside of the settings.json. This opens another port, so you have to be aware of that. And right now, there appears to be some common Postgres clients that do not support certificate authentication. So right now, we're allowing you to define a username and passwords. You can go here. You can go here and define a user. It will generate a strong password for you. And now you will be able to issue queries using the Postgres protocol using this user and password. I'm not sure that I'm happy with that. I'm not sure if this is how it would remain, but for now, this is what we're doing. Now, this is just the first step, because the next step is actually making use of that in interesting ways. And now, the whole idea is that once we have the ability to talk in the Postgres format, we can integrate with additional things. So let me see. I'm going to go here, and I'm going to select Postgres as a data source. It's going to think a while, and think some more. Really nasty queries are happening right now. Thank you for protecting me for security. Oh, come on. What's your error? 1 second. This appears to be okay. I do not like that it does that when. Let me check this. Okay, so something was wrong. Let's. Where are you? Here you go. Let's try that again. Sorry, that's the risk when you're doing live demos. And I wonder if that virus scan error was something. I do not want a virus scan in the middle of a webinar. I think that Windows has decided to make my life harder just because it can. Okay. Sorry, that's quite annoying. Okay, so now we are good. Zoom is apparently using a lot of power. I don't care. And I'm not sure. Let's try going back here. I want you to stop giving me that. Okay. Why are you asking that all the time? Okay. Okay, good. That's what I expected to happen. So I have categories here. Let's go for products. Let's go with orders. But you can see here, this is JSON. This is when I'm running the, this is where I'm running an array, and I don't have a way of actually, so flat documents, flat fields, very easy to store. More complex things I have to send as JSON, and I can also, I will show you shortly, I can also project that in easier ways. But right now, let's go with this. We're pulling the categories and the products into Power BI, where there is, okay. Good. Now, there used to be some data here. Oh, good. So what I want to do now, I want to create a new relationship between products category and this one. That's good. Now let's create a new visual. And this is this. And this is this. And now you can see here the number of products per, this is the number of products per category. And this is, I mean, I'm playing with that because this is funny, but here are the details. I don't know, no. That actually might be interesting. I can pull a, I don't know how it would find the location fields here, but you can imagine how this is doing some really, really cool stuff here. And as you can see, there isn't really much there to do. Pull the data, make it work, and now I can run all sorts of interesting reports directly on top of the data that I have inside of RavenDB. The PostgreSQL protocol in general is the PostgreSQL protocol in general is experimental. Using that inside of for Power BI is supported. This is something that we can run. As you can imagine, this is limited to the enterprise edition only. We have a question from Robert Angels. Can we have a local emulator to RavenDB to run it, or a container or something like Cosmos DB emulator? Well, the good question, the good answer for that is that yes, this is running RavenDB in its on-premise capacity. I basically went and download this thing, and you can just basically, I don't know what you want from me. So I was speaking to the security groups. You can go here, select whichever of the many things that we support, and you're basically done. You can also just run, basically I think it's docker run RavenDB/RavenDB, and you're done. You have a running instance of RavenDB that you can start running. This is something that's important to me to note. This is not emulation. This is the full RavenDB running as intended, because RavenDB can run both on-premise and in the cloud. Okay, so this is Power BI. I'm really excited about that because it opens up a lot of really interesting ways for you to play with your data. And that is a heavily requested feature for us. We also implemented TCP compression. This is for professional enterprise editions. And RavenDB has compression support for request compression support for HTTP. Now we are talking about all of the backend operations, application, subscription, all of those sorts of things that happen behind the scenes that you typically don't really pay attention to. As it turns out, we can do far better than the common gzip for HTTP request compression, and we are able to use ZSTD and save up to 85%. David in the beginning has mentioned that we are saving 50%. He is actually wrong. We're now at 85% of the network cost. And that's going to make cloud operations a lot cheaper because you pay for bandwidth there. This is not really something that you have to think about it. You upgrade to 5.3 and suddenly all of the internal communication is going to run in compress and save you on bandwidth. There are some quality of life improvements. This is how I call them. And the basic idea is that, for example, we have identities that you can now look at in the studio. This is not a new feature. This is something that I actually had for 7, 8, 10 years, something like that. But the whole idea is that it was hidden somewhat. So I hope that making this front-end center is going to make it more accessible to users. We've also spent a lot of time revoking the query page and the query operations. We actually had implemented a really sophisticated query processing analysis, and now you can have so now you can see how that works. I think this is actually end, not the search. So a lot of that is something that you might be used to. You might even consider that, take that for granted. I mention that because this was a huge task for us, and hopefully we'll never even notice. We just see that, oh, I get to see everything and everything is working for me, so I don't really have to think about that. Okay. I'm running through a lot of them very quickly. I know we have a lot of features that I want to cover. So we also now support JSON Patch. And this is how it looks like from the point of view of the API. You can send a patch to RavenDB, and RavenDB would basically is a thin wrapper for your backend is a thin wrapper, send it to RavenDB, and RavenDB apply that directly to the document. All of the usual features are there. This is transactional operation, blah, 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 blah. JSON Patch is typically used to reduce the amount of data that you send over the wire. You would typically modify the document on the client side, generate the patch from using some sort of library on the client side, send it to the server. The server will then apply that inside of RavenDB using this approach, and you're done. Okay. And Robert is leaving us. Goodbye, Robert. Our almost final feature, we have the notion of include revisions. Including documents is a core feature for RavenDB. It allows you to reduce the amount of network traffic that you have significantly. What we want to do, we want you to make revisions a core part of your model. So for example, in here, you can see that I'm saying, okay, this is a particular order and it was approved as of this revision. So now if I want to look into that and maybe see what was the previous approved and what changes I need to see, I can now run this sort of query. And obviously there is also the client API for that. And that would mean that I get all of the result in one shot. I don't really have to think about that. So from orders, well, ID. Include revisions. That's your problem. Ah, okay. Well, notice that I don't have revisions here. That sucks. But oh, sorry, it looks like we haven't added that here either. Oh well. And now here the result. Oh, come on. And I'm absolutely certain that this is how it's supposed to be. Revisions approved. Approved. 1 second, maybe we deleted that. Okay. Let's try it with this one then. Okay, this is ridiculous. I honestly think that someone is conspiring against me because it should be showing it here. I'm not sure why it's not showing that. I'm going to be pretty upset about this afterward and probably put the code under. Oh, okay. Christopher, thank you. Christopher mentioned that I have a typo, and now it would still not work. 1 second. Still does not work because this is annoying. Let's go to, that's what I used before, and assuming that I know how to spell, that should be what works. So, okay, I'm not sure what's going on here, but it should have worked. I will figure out later. I don't want to hold your time on that. So 13, 14 demos, and oh, Matthias is saying that I added something else in there. Oh, yeah. Okay. Let's do it one last time. What's now? I think this is like, this is this, not this, yes. Here we go. Yes. So Matthias and Christopher, thank you very much for catching up on all of my mistakes. Apparently, I need to take some spelling lessons and maybe get my eyesight corrected. So, I guess still, out of 30 demos, 2 going somewhat bad, I think I would take that as a win. So this is what I have prepared. This is a tremendous number of features and new things that we bring to the table. I'm really excited about concurrent subscriptions, about the Power BI integration, about the incremental time series. And that's it. Now is your time to ask questions. And thank you so much for helping me during the during my stumbling around here. Do you have any questions? Thing you would like me to discuss? Okay, so we have Christopher. Postgres Connector is currently experimental. Will it be part of professional and enterprise edition of RavenDB later? We haven't made that determination yet. I would very likely expect that this will be the case, but I don't want to make any commitment. In general, we are trying to provide every new release with features that go to the community edition and up, but we still need to make money somehow, so we are having to tier some features. Matthias has a question. Can you explain what identities are? Yes, absolutely. So sometimes in my head, this makes so much sense because I already know what I know. Okay, so let's go back here and let's talk about this. let's say that I want to generate, like in this case, an invoice, and I need a sequential number. Now, I can run and I can ask RavenDB, generate me an invoice like this. So notice that when I created the ID, I put a slash in here. And that slash basically tells RavenDB, I want you to generate an ID for that. And to generate something like that. If you operate it, and this is just some incremental number that is local to the current node, it has absolutely no meaning whatsoever. If you're operating from the client side, you will typically have IDs that look like this. This is built using something called HILO. This is an algorithm that we have that allow you to run in a distributed manner and generate the appropriately unique IDs without having too much coordination. But there are cases, and invoices is one of those common cases, where you need an absolutely sequential ID, and you have to do that with the full capabilities of the cluster. So you would rather have a failure than getting a duplicate value or skipping over value. So you can do it like this. Notice that this is not a slash, this is a pipe. And when I'm saving that, this is going to be set to the next value, and this is going to set this as the next value. Why do we have that? You can see here all of the details about that. And I'm going to paste this link in the chat. And this basically allows me to generate sequential IDs in the cluster, which is very nice for those sort of things. There is also, I think, really good discussion of that in here, where, so I'm putting that in the chat as well. Okay, I hope that this answers the question, Matthias. Basically, identity is a way for you to store, to have a sequentially incremental number that is backed by the cluster-wide guarantees of RavenDB. Okay. Any more questions, things you would like to know? While we're waiting, I will remind you, RavenDB gives you the ability to run completely free in the cloud. You can also go and download RavenDB and run it on premise. As a reminder, the emulator thing keeps bumping in my head because what you run on premise is the full feature server, not just something that you play with. And RavenDB is a multi-master database, and it's very commonly used in scenarios where you're working in multi-cloud, hybrid cloud, and on-premise, those sorts of things. If you have any questions afterward, feel free to ping me. I'll be very happy to answer anything that you have. Thank you very much and have a great day.